Welcome to Unit 13 of Online Chemistry 101 at Goodwin College. This week's unit is actually going to cover two chapters. We're going to cover Chapter 12 in your textbook, which is probably not titled More Organic Chemistry, but that's what I'm going to title it. We're not going to spend a lot of time on Chapter 12. In fact, I'm going to ignore an incredibly large chunk of Chapter 12, so you won't have much to learn there. Chapter 13 we're going to cover pretty much all of in your book. So let's start with Chapter 12. As a review for Chapter 12, I want to just sort of remind you of what an isomer is. We talked about this in one of the previous units. An isomer or isomers are molecules that have the same simple formula but have the atoms attached to each other in different ways. So this molecule up here on top has the simple formula of C4H10. So does this molecule here on the bottom. Even though they have the same simple formula, the atoms are attached to each other in different ways, and because of that, the top molecule and the bottom molecule are completely different things. They have different behaviors, they're different molecules, and because they're different, they have different names. One way of thinking about them is to call them isomers of each other. What that mean, and that just means they have the same simple formula, but they're not the same thing. So again, hopefully you can see that they have the same simple formula, not the same molecule. And that's going to become important for Chapter 12. So the atoms are attached to each other in different ways. There's a different kind of isomer than this. This one has a special name. I'm not going to get bogged down in the name because I think the name can actually be a little bit confusing. All I want you to know is this one hopefully is pretty easy to see and understand. You can see that the molecule on top is different than the molecule on the bottom. The molecule on the bottom kind of has this triangular shape. It has sort of three edges, and the molecule on the top isn't really like a triangle. It's more like a zigzaggy line. So it's probably immediately clear that the top and bottom molecules there are different from each other. But there is a different kind of isomer that we're going to talk about. It's talked about in Chapter 12. It's called a stereoisomer, and this is taken from your textbook. It says a stereoisomer is where the atoms are bonded in the same sequence but differ in the way that they're arranged in space. And when I read this is pretty much what I think. I have no idea what that really means. And so if you have no idea what that really means, you're probably in reasonably good company. But I will try to explain what that really means now. And the way to think about this is to perform the following thought experiment. Here are two gloves, two winter gloves. You're probably not using them right now. Are they the same glove? Are they identical to each other? You can pause and think about this and sort of answer in your head if you want. And come up with an explanation for why they are the same or why they aren't the same. The reality is that they're not the same glove. This is a right-handed glove. This over here is a left-handed glove. And if you have ever tried to put your left hand in a right-handed glove, or vice versa, you know that your left hand won't fit well into a right-handed glove. And the same is true if you try to fit your right hand into a left-handed glove. Because of that, left-handed gloves and right-handed gloves are not the same. They look very similar to each other, but they're really not the same. And so, again, that's basically the answer to that question, and it's going to help us understand what a stereoisomer is. So these gloves are not the same. They're not identical to each other. They are stereoisomers of each other. Again, I haven't explained exactly what a stereoisomer is, but at least you can see two things that are stereoisomers of each other. What that really means, stereoisomer, is that there's a left-handed one and a right-handed one. They're mirror images of each other, and they're not the same thing. So stereoisomer basically means something that comes in a left-handed form and a right-handed form, and the left-handed and right-handed forms are not identical to each other. And what you say in chemistry, there's a formal term for having a left-handed feature or a right-handed feature. The term is chiral, so I'm just circling it here. What you say is these gloves have a chiral feature. What that means is they either come in a left-handed form or a right-handed form. Some molecules, as you might guess, also have chiral features. They come in left-handed and right-handed forms. And another way of thinking about this, and maybe this is probably a better way to think about it, is that some molecules can be mirror images of each other and not be identical to each other. And this actually turns out to be incredibly important in biology and medicine, and I'll give you a couple of examples near the end of this particular chapter. So, stereoisomer. Some molecules are mirror images of each other. At this point, I want you to ignore this part that I'm circling here. I want you to focus on this molecule on the left, this molecule on the right here. First, the one on the left. This one on the left, this molecule here, it has a carbon atom in the middle. That's the black sphere here. It has a hydrogen sort of pointing north, an iodine pointing toward us because this thing has a three-dimensional shape. The carbon also has a chlorine attached, sort of pointing east and sort of to the back, and a bromine atom. So it has these four different things attached to it. If you look over at this molecule here, this molecule also has a carbon atom in the center, a chlorine, a bromine, hydrogen, and iodine. It has the same four things attached, but this molecule on the left and this molecule on the right are not actually identical to each other. And you might not necessarily notice that if you were a beginning student, and if you just sort of looked at these casually, you might say, well, they're the same thing. In the same way that you might look at a left-handed glove and a right-handed glove and say, well, they're the same thing. But these molecules aren't the same thing. The reality is that they are mirror images of each other. And if you held up a mirror, like they're showing you here from your textbook, the reflection in the mirror, the reflection of this molecule in the mirror, would look exactly like this molecule off to the right. And if you held this molecule off to the right up to a mirror, its reflection would look like this. So what you can think of these molecules as sort of, you could say, well, informally, you could say this is the left-handed version of the molecule and this is the right-handed version of the molecule. And they're not identical to each other. So some of the more skeptical students might sit there and say, yes, they are identical. They have the same four things attached. There's a carbon in the center. The true test of whether they're identical or not is if you could build these in real life in 3 dimensions. And you can. I guess you have some marshmallows and raisins laying around, or if you have a fancier modeling set, you could build these two. And if you could try to turn this molecule so that all of its atoms lined up with all of the atoms on this molecule, what you would see is that you can never get them all to line up. And that's what they're trying to show you in this picture here on the right. They're saying, look, if we put the carbon in the middle, we can line up the hydrogen of one molecule with the hydrogen of the other, and iodine of one molecule with the iodine of the other, but we can never get the other two atoms to line up properly because we can't put all of the atoms in the right spot. Even though the left molecule looks similar to the right molecule, they're not actually the same thing because you can never line up all of the atoms in each of the molecules with each other. And because of that, they are stereoisomers. Same simple formula, but they are mirror images of each other that are not identical to each other. So these are mirror image molecules. They're mirror images of each other. They're not the same molecule. They are stereoisomers of each other. This carbon in the center here is actually somewhat important, and it gets a special name if it's sort of the carbon. You'll see it's sort of the carbon that helps to make these mirror image molecules. Those carbons are called chiral carbons. Sometimes they're called chiral centers because they're at the center of these 4 other atoms. But if you have a carbon atom, and I'll explain what makes it a chiral carbon. But basically, if you have a carbon atom that helps to make a left-handed or right-handed stereoisomer, it's called a chiral carbon or a chiral center. So here's what actually helps to make this carbon a chiral carbon or a chiral center. If you have a molecule that has a carbon that is bonded to 4 different things, and I'm being a little bit vague about what things is, but you'll see why I mean that in the next chapter. But if you have a molecule and there's a carbon atom and the carbon is bonded to 4 different things, and here this carbon atom is bonded to 4 different things. There's a hydrogen, chlorine, iodine, and bromine. They're not the same thing. Then that molecule is going to have a mirror image that is not identical to itself. And in this case, here's the mirror image that isn't identical to itself. This carbon has 4 different things attached to it, so it will have a mirror image that's not identical to itself, or it'll have a stereoisomer. And this type of carbon that has 4 different things attached is called a chiral carbon, or sometimes a chiral center. And another thing to point out, which we haven't discussed so much in this course, but I'm going to point it out now, I have told you in the past that these molecules have a specific 3-dimensional shape. And here, this is taken from your book, and they're basically trying to show you that 3-dimensional shape. They're trying to say, look, you can think of the carbon atom as kind of being in the center, and the iodine and the hydrogen are pointing toward us in 3-dimensional space, and the bromine and the chlorine atoms are sort of pointing away from us. And, you know, if you're a good enough artist, you can draw this kind of thing and you can see it. However, it becomes a little bit of a pain to continuously draw these things in 3 dimensions. So sometimes when chemists are concerned with the 3-dimensional shape of molecules or atoms, and they want to sort of show which ones are pointing toward you and which ones are pointing away from you, they draw the bonds in this way. So this little cartoon here is kind of a skeletal structure of this molecule here on the left. And I said that the hydrogen and iodine were pointing toward us. So that the way that the chemists usually draw this is that they will draw a fat sort of triangular bond. And this thick, solid, fat bond here, one going to the hydrogen, one going to the iodine, means that these atoms are supposed to be pointing toward us in 3 dimensions. And if the atoms are pointing away from you, what you do is you draw a little triangular bond, but you draw it with dashes. So this is called a wedge. Usually it's called a solid wedge. Solid wedge means that the atom is pointing toward you in 3 dimensions. A dashed wedge, which is what this thing is called, means that the atom is pointing away from you in 3 dimensions. And the carbon is sitting here at this intersection, and you can think of it as sort of you know, with respect to the other atoms, it's not pointing toward us and it's not pointing away from us. And then this is, this particular molecule is just drawn here. Again, same type of thing. The solid wedges mean the atoms are pointing toward us. The dashed wedges mean the atoms are pointing away from us. And hopefully you can appreciate that it's easier to draw this than it is to draw these sort of fancy 3-dimensional artistic cartoons of what the molecules look like. So most chemists, when they're interested in sort of who's pointing toward you, who's pointing away, they'll draw it like this. I want to summarize a little bit about stereoisomers, or what I'm informally calling mirror image molecules. So, and since pretty much the rest of the course deals with organic molecules, I'm going to talk exclusively about organic molecules. So all organic molecules have mirror images. They all have molecules that are mirror images of each other. However, if you have a molecule with 4 different things attached to a carbon atom, if you have an organic molecule like that, then the mirror image molecules will not be identical to each other. They will be stereoisomers. And the example is taken from the previous slide. These are stereoisomers of each other. There's a carbon in the middle. There are 4 different atoms attached on either one. And because there are 4 different things attached to that carbon, this particular molecule has a mirror image. Here it is on the right. And this mirror image is not the same thing as the mirror image on the left. So these things are stereoisomers of each other. However, you can have organic molecules where there are less than 4. So here's a mathematical way of writing less than 4. If you have an organic molecule with less than 4 different things attached to the carbon, then the mirror images are actually the same molecule. And that's sort of shown here. I'm not sure why the computer program colorized these things this time, but you don't have to, you can ignore the colors. But here's a carbon in the center. But this carbon, this particular molecule, the carbon in it doesn't have 4 different things attached. It has hydrogen, fluorine, and it has chlorine. It only has 3 different things attached. And because of that, this molecule on the left does have a mirror image. Here's the mirror image. But the mirror image is actually the same molecule. It's an identical molecule. So these things don't get different names. They're actually just the same thing. So the way that you have to make a stereoisomer with an organic molecule is that you have to have at least 1 carbon atom with 4 different things attached to that carbon atom. If you have that, then your molecule will have mirror images that are not identical to the original molecule. And in the next section, I am going to talk about why we're spending so much time on these stereoisomers, or these mirror image molecules.